Today we're back with another MGA episode. We've got some high voltage things, high voltage connectors, running a lot of wires. Let's get to it. This week's sponsor is DroneQuote. So DroneQuote firmly believes in advocacy. They really want to make sure that their homeowners have all the information to make informed decisions. And believe it or not, sometimes solar is not the best option for you, and they will let you know. Their mission is to serve as dedicated advocates for the homeowners to help guide them through the process with transparency, honesty, and integrity. So at DroneQuote, they understand that switching to solar is a very big decision, and they want to be there to guide you through every step of the way. So again, one of the cool things is rather than kind of a sales approach, they are actually on your side. They're on the homeowner side. And because they've worked with so many people, they can really leverage their information and their knowledge to help provide the best information for you to make a decision. If the homeowner does decide to go with solar, they will use their state-of-the-art drones to conduct thorough surveys of the property and the roof, both before and after installation. So now is the perfect time to use a company like DroneQuote because it is the summer months when energy prices and things get that much higher, and the benefit of solar can really help you out. So make sure to visit DroneQuote and beat the rush. In order to complete the whole system, we actually have a brake transducer that can help with like regen on braking and just let the car know when the brake pedal's been pushed. So this one needs to get tied into the brake lines. So I've got a T that I'm going to put right here. This brake line doesn't look in pristine condition, meaning it's all bent and warped, so I don't feel too bad about cutting it. However, it does mean I need to bleed the brakes, but when I checked inside, there is no fluid. So you can see there is no fluid in there. So we are good to go ahead and cut this and make our connection. So these are steel brake lines, not stainless steel, but steel brake lines. So these are really old, and I don't know if they've just seen better days. I do have some other brake lines. We'll see. I might just end up using that. I highly recommend one of these brake flare tools. It gives you really good results almost every time. I'll put a link in the description below. And because these are steel, I scuffed it up and gave it a new coat of the roll bar chassis paint to protect it from the elements. So I put all the brake lines and clutch lines back in place, tighten things down. The system is ready to fill and bleed. So next was wiring the brake transducer. Last time I did some crimping, people mentioned that you can put these little weather seals inside that place where the insulation goes, so that way it's kind of stuck in there. So I did that this time. We'll see. I think it'll work just fine. I need to add a fuse holder to this bracket, and I wasn't aware at that time, so I need to just do it after the fact and doing some rib nuts or nut certs. So I got my 8-gauge wire, stripped some off, used some of these mechanical crimpers to crimp on the connection. And again, this is for the onboard charger. We're going to talk just for a second about the CAN circuit. Look at all this lovely wiring we get to deal with. So for this particular car, we've got a couple different systems that are operating on the CAN circuit. So one is the charger. We've got another one, the current sensor that is inside the high voltage junction box. And I just did a resistance check. They told me that there is a resistor in here, and I confirmed that there is. So that's going to be the termination point for one end of the CAN circuit. There are a couple other things. So in each of the battery boxes, there's satellite BMS units, and they need CAN. So there's one up front, one in the rear, and there's also the BMS module, as well as there's a screen, a BMS screen. All those things need to have the CAN cable run to them. Now, here's a part that some people, including myself, get mixed up. So basically, one termination point is here. So that's got to be the end. From there, we've got to loop the cable around, even if it has to loop there and back, such that each of the branches are only like 2 feet or less. So this one's going to be mounted back here. So I need to run from there. I need to go back to the battery box to pick up those BMS satellite units. We need to run it to the front as well. These BMS satellite units, as well as the charger, and then loop back. And I think the screen, so probably have it somewhere in here, will be the other termination point. So wiring the CAN circuit is not just as simple as all the other wiring. It's not just connecting the wires from one point to another. You have to consider the branches can't be too long. You have to consider where the termination resistors are. So yeah, just a little more thought goes into that. So here we are just splicing the CAN wires from the main trunk to the charger. And then from the front battery box BMS to the main trunk. There was a termination resistor we had to get rid of because you can't have too many. You can see here the cable that kind of comes with the equipment. They've got 18 gauge wire, and then what they've connected I think is like 22 gauge. So definitely not going to keep that. We'll go for the 18 gauge, which is what it's appropriately rated for. And then we've already removed the resistor for the CAN. We'll keep that just in case we need it for somewhere else down the line. Man, that was a lot of wiring. So let me just tell you real quick what we're doing. The top part of the battery box has the BMS units in it. It also has a contactor. So we need to wire those pins to this plug. So we got that done. Then essentially these are all the wires coming out of the controller. And as you can see here from my sheet, there's a lot to do. So some of these went to the brake transducer, so we ran some of them over here. Others went to the charger, so we had wires going over there to the charger as well. And then we have some of the larger cables, both from the charger, so going into the charger as well as out of the charger. Out of the charger, I think it's like 8 gauge. Into the charger, I think it's like 14 gauge. I think, knock on wood, we've got all the wiring done up to the firewall. The electricgt kit came with a wiring harness, which is good. It's already got all the pins and connectors made with this wiring loom. However, nothing is labeled. They do have a diagram, wiring diagram, which is helpful, but like the coloring, some of the colors are used twice, like white, red, black. So I just have to figure out which wires are which and label them. All right, I also just noticed that they use the same pin for two different things. So like 12-volt supply, those are both pin 10, but you got two wires coming out. There's only one wire coming out. They've got that a couple different times, like pin 12, those are both ground, but two wires. So you got one pin, two wires, but there's really only one wire. So not only that, but they do have some empty slots. So I could understand if they're all full but one, but like 34 is not used, you know, 27's not used, 28's not used. So anyway, listen to me gripe. Sorry about that. All right, did a quick pin out. Looks like all the motor wires are in this one. So again, there's 6 wires in here, and this will run to the motor. So I just need to get the exact length, cut this down, strip it, put connectors on. So for anybody that's done this, it is a tedious process of pinning out, making sure you've got all the wires correctly labeled, and then routing them to all the various locations. And I'm one who likes clean and tidy wires. So it was also time to route and wire the high voltage lines. This means making all the high voltage connections. Some are pretty simple, like these lugs. This hydraulic crimper is a must. I will leave a link in the description below. The other ones are unique. I swear every high voltage connector I've seen is a little bit different. So my advice is to take your time because these are expensive. I can neither confirm nor deny that I used more than one and had to replace more than one. I do like to put the orange sheathing over it just to add another layer of protection to the high voltage cables. Again, these are another style of connector. And it's always important to really think through so you can put all the back half on first, because it's always tempting just to start by crimping, and lots of times you need to put things on before you start crimping. These end plates were really challenging to get on. I ended up using some vice grips to kind of try to push things down as hard as I could, and then I could slide it on. One done. By the way, what I use to cut the lines as well as strip off the sections is just a PVC cutter that is often used in sprinkler applications. Cut way too many of these. Try again. For anybody doing these types of plugs, the order of operations, you've got to thread on this back piece, this kind of grommet weather seal, and then you've also got to thread it through this housing. And then you crimp it on, you put it down. This thing is like impossible to put on, but you have to press this one all the way down, then slide this one on top, and then these ones snap together. I feel like I haven't been recording very much. It's probably hard to make wiring look exciting. So under the car, can you tell? But basically I'm creating some channels. At first I was just thinking maybe like some PVC pipes or something just to kind of get these out of the way and have them be a little bit protected. But then I remembered I've got my friend Sen Cut Sen, and I made these channels. I've got one there, this one's a curved one up here, and I've got one more that's coming. It's a channel to get all these wires, plumbing, high voltage cables out of the way. And when we were working with these high voltage lines on the car, it's even more important to get things correct because usually things are cut to length and it's much more challenging if you make a mistake. I think that's close enough. All right, I pulled this one out again. I probably pulled it out, put it back like 5 times. I didn't realize, but there is a communication port back there. So I need to get that one open. I've got a serial RS-232 to USB, and I need to communicate to the motor controller to make sure that we've got the proper settings. And so while it's out, I'm gonna connect these other 2 lines to the positive and negative, and then put it back for good. Probably also make like a 3D printed cover, just cover high voltage stuff. All right, I got a 3D printed, I'll call it cover. This one's gonna go on top of the motor controller. So right there, it got a lot of high voltage and things going. Thought this would be appropriate to cover it. I will likely have to take the rear battery box out. Just, there always seems to be some issue that we have to dive into these. But just in case we're lucky, I wanted to seal it so we can make sure it's all road ready. Here we are putting back the 72 fasteners. I might get copyrighted for my own video. So this was one of the original reasons why I wanted to film and put things out there, is I wanted to make sure I got things that I could look back and make sure they're in the right place. So they've got 4 of these plates that connect, and just wondering which one went. So here we are trying to put the rear battery box in, and it's got to go up another few inches, and you can see the cooling ports, yeah, definitely not going to work. I'll have to take these off, and then the question is, do I redesign them? Because they just stick out a lot. They don't need to stick out that much. For right now, I'll take them off, and then we'll see if we have a problem with the plugs, because the plugs are also very close to the leaf springs. All right, so I believe those electrical plugs are kind of above the leaf spring. So I think those are gonna be okay, but those cooling ports, definitely not okay. So we'll redesign something to make those be compatible. I put these brackets on before putting this in. I thought I'd have a lot more access, which I did, but I don't think there is a way to put on these other brackets while those are in place. So we'll take them off and redo everything. All right, so I've removed the old gas, I don't know what you want to call this one, but where the gas filler neck went, and I'm going to replace it with a send cut send part that routes the charging wire. So after routing all the charging wires through the trunk, we're now splicing with the rest of the bundle so they can get to the right location. And there's just one more low voltage connector to go. Again, I prefer crimping over soldering, but this particular connection required soldering. And then we always like those clean wires, so I like to use these cable sheaths. They're black and make all the wires look neat. I will also leave a link to that product in the video description below. All right, we got the two high voltage connectors made, the low voltage connector, Everything's super tight, so I gotta check, make sure that the spring, you know, when it's fully compressed, that we're not very close there. Maybe I'll see if I can sneak in here to some of these bolts and kind of shift it that way just a little bit. But yeah, so I've got these all tucked out of the way. Things are looking really nice there. And then this is where it'll pass through to behind the seats, and that's where the high voltage junction box will go. So here we are at the back of the car. As you recall, we've got our battery box back here, and these places are for the cooling port, and these are the original ones, and there's just no way, right? So they can't even get in position. The leaf spring's in the way. So came up with a new design, and those essentially have 90 degrees. They can fit there and just get things out of the way. So we'll go ahead and put those on. Come on. There we go. All right, they are both secure now. There is clearance in between, so we should be good to go. I've got these lines that I need to connect. I'm gonna wait for that to set up. I've also got all these lines that are, I've got them secure out of the way and things, but I've got a box that's in there, and I wanna make sure that I've got things situated before I cut things to length and make things final. All right, we made a lot of good progress. We've got a lot of the high voltage cables run. We are just about there. I think all we need to do is put in batteries, put the top on. We need to mount that switch. Other than that, we've got a section here in the back that we need to make some mounting brackets for a lot of the components. And then that'll be about time to see if we can turn things on, start talking to it. So thanks everybody for tuning in. That'll do it for this time. See you next time. This one, it won't focus. Is that really what it is? My butt. Okay. So the plug, when it plugs in. Firing again. That's not good. Let's try again.